So today we are starting compound interest, and this is something that you have actually done in your previous classes, so it's really just a review. So we're going to be using two different formulas. One is for compound interest for discrete numbers of compounding times. But just so that you remember what compounding is, you put in a certain amount of money or whatever into a bank, usually money. Your new amount after a particular amount of time will include the principal that you deposited plus any interest that you have earned. And your interest, so your principal, you've got the new amounts are A, and the P is the principal, and 1, you're going to multiply it times 1 because that's how much you're multiplying principal times 1 so that you have the amount there that you started with, plus the R, which is always given to you in percent, but you will generally record it as a decimal. Rate over N, the number of compounding periods, number of times compound per year, compounded, and N is the same here, and then T is the number of years. We'll do that a little bit further down here. And the common payment period, you can annually be once a year, semi-annually, of course, is twice. Quarterly is 3 times, monthly 12, and then daily is 365. There's others, but typically there's those. And then you can continuously compound. And we're going to use what we call the PERT formula. It's an affectionate nickname. It's not an official name, I assure you. But it's really the same kind of thing, except that there's continuous compounding. And so we use the constant E raised to the rate times T. So let's just define every one of the amounts. So the ending amount is A, and the P is the principal, which this is the amount you actually put in the bank initially. This is the R is the annual, and that's important to note. The annual interest rate. If sometimes they give you the rate per month, and you will have to calculate what the yearly rate would be. But this should always be used as a decimal, not as a percent, even though it's often usually given as a percent. N is the number of times interest is paid in a year. And T is the number of years. E is a constant, 2.71, blah, blah, blah. But always use the E key on your calculator. Don't type in 2.7. Okay, so we've got that defined. Let's move on and start doing some problems. We don't have too much to do today. I'm leaving you a second video as well. Okay, so find the amount invested. We won't do all of these. We'll just do a few of them because they're pretty simple. And the other ones are actually more complicated. So find the amount that results from each investment. And again, we're going to be using this formula for a discrete number of compounding periods. Okay, so $50 invested at 6% compounded monthly. So that's N equals 12, and 6%, 0.06, is equal to the R. This is P, and 3 is T. So we're ready to go. So A is equal to $50 times 1 plus 0.06 over 12 raised to the 12 times 3. And you just typically just put that into your calculator and get 59. It really is just a calculator activity. So that'll equal $59.83 And this one is typical, the same. The answer, try it though and see what you get. You should come up with an answer. Let me find that answer for you on page. You're on page 24 of your notes. And so the answer that you would get for this one would be $789.24. So try it. Make sure you can do that. An investment is made in a trust fund at an annual percentage rate of 9.5% compounded quarterly. How long is it going to take for the investment to double in value? See, it's, I think, kind of interesting that if you start out with $200 and you invest it at maybe at 9.5%, 0.095 over quarterly, so 4, raised to the 4 times, well, we don't know, t. If you end up with $400, if you double it, you'll end up with 2 over here and 1 here. If you started out with $1,000 here, you'd end up with $2,000, and still the number would be 2. So we can just use 2. When they want to know if it's doubled, we'd use 2. They say it's half, we'd use half, and etc. So this is equal to 1 plus 0.095 divided by 4, raised to the 4, because it's the number t. It's quarterly. And we calculate, we see that the t is in the exponent spot. So we can't do typical just calculator calculations. We have to actually manipulate the data, the numbers a little bit. And so we're going to take the ln of both sides because it's the only way to move the t to the command line. So this we're going to do, it'll equal 4t times the ln of 1 plus 0.095 over 4. And we divide both sides by 4. And then we're going to divide both sides by this also, 1 plus 0.095 over 4. Okay, and that will leave, this is the ln of that, and that will leave t. So t will equal the ln of 2 over the ln of 1 plus 0.095 over 4 times 4. Okay. And that is 7.383 years. Okay, so B. What if how long will it take to double if it's continuously compounded? So again, we're going to use the 2, but this time we're going to, our principal is already taken into account because we have doubled it. So it's 2 times whatever we started with, whatever that amount would be, times E to the R, which is 0.095 t. We don't know what that will be. Again, we're going to take the ln of both sides. So we take the ln of 2 is equal to the ln of e to the 0.095 t. Bring the 0.095 t to the front because it's an exponent. Power. So 0.095 t times the ln of e, which is equal to 1, by the way. And we're going to divide both sides by 0.095 to find t. And we put that in your calculator. You'll get t is equal to, verify this, 7.296 years. Okay, and then we have the next one. An investment of $10,000 is compounded continuously. What percentage rate will produce a balance of $25,000 in 10 years? So we're going to use the PERT formula. And we're going to end up with $25,000 after 10 years. But we start with 10,000. E to the R, we don't know, times 10. Divide both sides by 10,000, so we get 25,000, or 25 over 10, equals E to the 10R. And we're going to ln of both sides. So we end up with the ln of 25 over 10 will equal 10R, okay, because the ln of E equals 1. And then we take the ln of 25 tenths divided by 10 equals R. We're going to divide both sides by R. By 10, sorry. And so R is actually 9.163%. Okay, next one. John needs $4,000 in 2 years to pay off a loan that he can't pay off early. That's what this means. He has $5,000 now, but how much he doesn't want to save the whole thing. How much should he save in an account paying 5% compounded monthly? So that's 12. R equals N equals 12. So that in 2 years he'll have exactly $4,000. So 4,000 is the amount we're going to end up with, is equal to the amount he should invest. 1 plus 0.05 is the interest rate, and monthly, and then 2 times 12. So again, you just do the arithmetic here. Divide both sides by 1 plus 0.05 to the 24th power gives you P. And so P will equal $3,620.10. That's it. Okay. Number 5 is similar to that. You can calculate R. In this case, that's just a calculator activity. It's just very similar. And then number 6, you're investing $5,000, and your rate of increase is going to happen like this. This is your formula for increasing. So they want to know how much will your investment be worth in 4 years. So it's just F at 4 will equal 5,000 times 1.0425 raised to the 4th power. And X is in years. So this is, again, just a calculator activity. So it's $5,905.74. And then they're asking also, when will your investment be worth $14,000? So that's the amount you're going to end up with, $14,000, but you start with $5,000 using the formula that they have given you. And divide both sides by 5,000. So you get 14/5 equals 1.0425 to the T power. Again, ln both sides. So you end up with T times the ln of 1.0425, and that's the ln of 14/5. Divide both sides by the ln of 1.0425 to get T. And that will be 24.738 years. Okay, that's pretty short and a quick review of Algebra 2 compounding problems that you had. Okay, your homework is on worksheets 13 and 15, and you've got a quiz next class, I believe, on Friday. And then next week we'll review and have a unit test over logarithms. But please note that worksheet, you have worksheet 13, worksheet 15, and worksheet 15 is pages 33 to 35. Don't stop after 34. There's a lot of good practice there. You had a review sheet last class to do. That was to begin the beginning of the review for the test, for the quiz rather, that you're going to have on Friday. What you're doing today is also review for the Friday. You're not going to have interest problems on your quiz, but you will need to know how to do the log equations and exponential equations, which you will see, especially on the last page of worksheet 15. Okay, get started. Bye-bye.